Hello guys, welcome back. So in this tutorial we are going to see how we can extract the model parameters from the experimental data. So in our previous video we saw how we can get the data from the previously published research paper. So if you haven't seen the previous video, please go and watch. That will help you to learn some things about data extraction, as well as if you don't have any experimental data, you can get the experimental data from other paper and you can learn how to do the model parameter estimation just by yourself. So the previous video might be helpful in order to get some idea about the data extraction. So now let's move into this particular tutorial. So as you can see here, I arranged the data based on the strain rate. So we have a 4 strain rate and 4 temperature. So this is the extraction I made based on the data extraction. So let's make a comparison of all the data. So for that, just make a plot. So do the same thing for other 3 temperature. So we did the comparison for all the data which we extracted from the experimental curve. So you might have the similar data for your own experiment also. So this is the entire data, but when we are making the flow stress model, we don't consider entire strain because the flow stress model is kind of approximate model we develop so that it can be used to make a future prediction. So there is always a theory behind the statistical model. When you are developing, you can use the reasonable number of sample. So the reasonable number of samples can be 10 or 15 or 20. So it's based on the user selection. So in this paper, as I mentioned before, they used only 9 points, from 0.1 strain rate till the 0.5. So what you can do, you just split the data from 0.1 to 0.5 and make a data separation. So as you can see here, I made a split of all the data based on the 9 samples. So you can also check, for example, if you just fill out the, just to go here and it's column till 9. Okay, yeah. So there are like a 9 sample I made in order to make a prediction. And also I have to explain one more thing. So here they consider till the 0.5, and in some cases you might see 0.25 also, and in some cases you can see 0.4 and some cases 0.8 also. So the strain range is based on your own experimental data and what kind of test you are doing with respect to different strain rate and different temperature. So the data can be anything. So the procedure is same. So you need a sample that you are going to make a model with respect to that particular range. So the starting point can be based on the yield point. So when you are making certain reference condition, so in this case they make 1323, which is 1323 Kelvin, and 10 as a strain rate to make a reference strain rate. So usually people take that reference conditions and try to find out the yield point, because the model is based on the plastic deformation, not based on the elastic deformation. So it is better to consider the flow stress values after the yield point, and that will give you good estimation of the plastic deformation, and that can be used for making any kinds of simulations based on the metal forming. So that is the idea I can give. But some people choose 0.5 and some people choose 0.1. It's based on their wish, and it's based on user friendly. So you can even go here like a 0.25 or 0.5 or 0.1, and the model can be okay because you are just going to approximate the model. So even if you consider here, you will make approximation model based on this particular data with respect to all other cases. So you will get the same outcome, and the little bit prediction will change based on the number of data sample. So you don't need to worry about that. So now they chose 9 sample, and you can also do like this. Instead of choosing like a 0.1, 0.2, you can also do 0.05, then 0.1, then 0.2, or 0.25, and some cases 0.275. You can increase the number of samples or you can reduce the number of sample, but you have to stick to the minimum sample that will improve the model approximation. So in this case they used 9, and you can use more than that. And one more idea I want to give, like when you are, for example, you just copy and paste it here, and now you want to take this data, right, like this, and then you can delete till here and then here, because you are just going to get that data. So when you are having this kind of things, you have to delete this one like a one by one, right? Delete and then shift up. So this will take so much time. So in this case, what you can do, just select all the data like this, and then you can go here, and you can go here, and you can go to the go to special, and here you can see blank option. Just OK. So when the blank is selected, just come here and delete. So in this case, you can save your time and you can do the thing very faster. So that's why I want to give this little idea, and it will help you to make your data arrangement very fast. So now we did the same thing for all other strain rate. So now the data is ready in order to make a model parameter estimation. And then check one more time your temperature, strain rate, and the melting point. As I said before, it's based on the like the web data. So I used 1510 and I added 273 in order to make that one as a Kelvin. And as we saw in the paper, they used reference temperature and the strain rate as 10. So that's why I put 1323 and 10, and the yield state at reference temperature is 100. That one you can get it from the paper, because they mentioned here the A, which is the first model parameter. So now it's clear that let's make the graph of this original equation, so that when you are making the model estimation, it will be much clear. So now we got the equation. So now you can see the original Johnson-Oak model, and you can see the material model parameters also. And I will explain how you can get the model parameter A. And let's go into the paper, and you can see they clearly explained the value of A can be obtained from the yield stress of the flow curve at reference temperature, which means you have to go to the experimental data and you have to check what is your reference temperature and reference strain rate, and find out the yield point from that particular flow curve and use that data as a model parameter A. And in your case, the yield point can be anything. For their case, they clearly mentioned they consider, or they calculated as a 100 megapascal yield point from their reference condition. And one more thing I would like to clarify here, the reference conditions is based on the user friendly. In this case, they chose high strain rate and low temperature, but in your case, you can choose either high strain rate and high temperature as a reference condition, because there is no rule that you have to choose either minimum or maximum. Because in my case, I chose high strain rate and high temperature as a reference condition, and the reference condition can differ based on the users, so you don't need to worry about that one. And it's also based on the strain range, so the user has to decide which range they want to make an approximate model in order to get the final results. So the selection is not based on the conditions. The user can play with any numbers or any limits. Okay, let's go and do the other things, which is the estimation of model parameter B and A. And this text comes from my research paper, and I have provided the link in the description, and you can go and download the paper and check how I did in my case. And then let's do for this one. So if you see here, we have to get the data from the reference temperature. As I said before, our reference condition is 1323 and 10. So go here and you just copy the data like this, and then go to here and then paste. So these things, in order to understand the step-by-step process, because we are going to do everything in Excel, in the next video I will explain how you can do in the MATLAB and how you can do that one as a permanent solution. It's like you just give an input and get the output. You don't need to do anything, and I will explain that one. And the next thing, you have to minus the data from the flow stress curve, which is the model parameter A. So just type model parameter A and then copy the value, which is 100. You don't need to copy, we know that one. So now we have to stress minus A, so which is this one. So you can do like this. So make a proper arrangements, and then you have to make a ln, which is a which is a natural logarithm. So equal, and then take a ln of that value. Take a ln of that value just like this, and then which is y. So now the y is ready this side, and then the strain is going to be the same. So you have to make a x, which is going to be ln of strain value that's it. So now you got the x and y. You have to understand this is the simple line equation, which is y equal to mx plus c. So we are going to get the m equal to n and c equal to ln b. So we are going to just make a linear fitting curve and get the data. So for that, just open the plot. Point plot is much better. Just select the data. The x is going to be the ln of epsilon. The y is going to be the ln of, not y, just y, not ln of y. Okay. And you got this right. So you can also check this one with the paper. This one, you get a similar thing here. Now just right click, you can see there is option add trend line. Click that one. You can click linear, but you have to make sure that you select the linear, not the polynomial, because in this case you can reduce the order, but if it is 2, it properly fit. But in this case we don't need a proper fit, we need a linear fit, because the equation is based on the linear equation, which is y equal to mx plus c. You have to choose the first order, and then here you can see display equation on chart. So now we got it. We got the model parameters. So let's make a little bit bigger. I don't know why I cannot increase this one. Maybe I have to increase the text size, which I can do here. So as I said before, the C, which is ln of B, is 4.3657, and the n is going to be 0.2768. So let's go to the paper and see. You can see the n value is 0.27. Let's copy and paste it here. This is from the paper. So we got exactly like this. There might be small difference because we made a data extraction, right? We didn't exactly did the thing, because there might be little bit change in the results because of the data extraction, which we did approximately. So this is the paper results. This one just for a comparison. Okay. But here we have the ln b, but we need a b. So for that, what you have to do, just to do the exponential. That's it. And then 78. Just to go here and you can see 78, but not very far away. So you can see the data is 78. which is very close. If you make approximation, then it's pretty okay. So we got the model parameter b and n. So now you might get idea how you can make the estimation of b and n. So now it's very clear. So now we find out a, b, n. So now let's make one more arrangements. Let's do everything here. Just type caps lock a, b, sorry it's c, and then n and c and m. It's supposed to be small letter. So this from the paper where I'm typing too much. So tutorial. Just highlight paper, this one, and tutorial. So let's copy. This is the paper data. This one I think n, and this one is 78 we saw before, and a is same because we got it from the paper directly, and make it as a normal. Don't worry, it will take just small time. So C and then 0.08, just copy and then paste it. I don't know why it comes like this. 0.08. Oh, seriously, I think I have to go here and then go to the paper. 58474. 58474. Okay, so in the tutorial this is same, and here we estimated 78.70. Paste it, and then the n value, copy and paste it. It was supposed to be just number. Okay, so out of 5 parameter we estimated 3 parameter. Let's do the remaining 2. So similarly, this also from my paper you can check the equation there. So in this case you have to choose the reference temperature, but you have to consider all the strain values. So just go to the each temperature, like this is the reference temperature. So copy this, come here, first strain rate, go here, and then second strain rate, copy, Control V, then the third strain rate, copy the reference temperature value, not everything, and then 10. Yes. So now we arranged all the data, but as you can see here, we need all the material parameter data which we estimated before, A, B, N. So just put all the data here, A, B, and then N. So the A is 100. You can just put it here, and then the B we estimated is here. The N is here, just copy and paste. This one just we are making the arrangements to make a calculation. So just put it like that. So just fill the color with something like this. So this is ABN. So if you see here, the equation is this one, but we want to do little bit more, which means we have to move this parenthesis to the left hand side. So by doing that, you can get like this. So I will take some time and I will make that equation. So now I put the equation here, which you can clearly see and you can understand. So we are just moving the parenthesis to the left hand side and we are making this term, and then the strain star can be calculated based on dividing the reference strain with respect to the selective strain, and we will do that one step by step. So first do the left hand side. So for that you just simply put like a y, because that one we are going to use. Oh, it's like a y1 because we have a 4 conditions, right? Just say like a y1 and then do that one like 4 times. So equal. So the first one is going to be this stress, select that one, just by. The next one is material parameter A, which is this, and then plus, and the next one is material parameter B, and then multiply by the strain value, which is this, and then the another parameter, which is N. Just enter. That's it. You can do like this. So you can also do one more thing, like you can delete these things and you just put a $sign. This also will give you like same results, but it is just for understanding, because it is for your first time, right? So I don't want to confuse you, so you will get the same thing, because this JKL is not going to change, which is model parameter. Only the stress and strain is going to change. That's why these things you just copy, and when you are pasting, just paste a special, and when you are changing, it's coming to C, right? So in that case, what you can do, instead of putting C, you just put D, because that is the stress value, and enter, and then boom, you got it. And then do the same thing, just copy and then paste it, and then change this to F, and then enter. Good. And then Control C, Control V, G, then change to H, which means I'm just choosing the stress rather than strain, because when you are copy paste in Excel, it will just take the value from this to this column. That is why we are just repeating and deleting the C column and changing to D, so that it will calculate the only strain. And then for strain, first we have to make this parenthesis, which is based on the reference strain and selective strain, which is nothing but just to consider dimensionless strain, but just to say D strain. That one is based on like this. So your reference strain can be, okay, that one. Let's do one more thing, just input like this, make it as a normal, and I will say reference strain is 10. So now we are going to use, reference strain rate. So our first strain is 0.01, so divide by 10, and then do like this, and then you have to do 4 times. So in this case, it's going to be 0.1, and then copy, because we have a 4 different strain, right? So, and the another one is 1, and then the last one is same as the reference strain rate. So just paste and 10, you will get 1. So now it's clear. You can also cross check with the paper if you confuse with the data. Yeah, see. So we are going to do the 4 times, but this one is a ln value, and I will show how you will get that one, and then do for a ln. So you can use this data, or you can just simply go here and make a ln. It is like time saving. So just to go here and then click and do the things, and then long, go to end and then close it. So the final you will get 0 because it's a 1, so the value will be 0. So now it's clear. So same as this, from -7 to 0. Yes, we got -7 to 0. It's pretty clear. We got the same data. So now we have to make a comparison. So for that we have to arrange all the data into the single column. So what you can do, just copy and then paste it here. Control X, Control X, and then so this is for strain rate 1, for strain rate 2, and this is for strain rate 3, and this is for strain rate 4. So now we got the X and Y. Now just to make a normal data plot, which is going to be this one, like same as this data. I think I made a little mistake. Let me check. 0.1, 0.2. I think no problem. But why? It looks little. The data looks like going like this. Let me check why. This is 0.01, which is the strain rate. This 61, okay, and then 90, 100, 139, 100, 190, 139. Yeah, actually I found the problem. So if you see here, everything is perfect, like a J, K, and this one is supposed to be by A plus B epsilon power n. So in this case it's A2, but in other cases, if you see here, it's A3, but when it comes here, it's just changing to B2, but it is supposed to be the same as C, but it is not. So the problem was here. So click enter, and then if you do this one, so this one supposed to be E. So click that one and then change, and this one supposed to be G. So now if you do this change here, just select and then copy paste. Yes, now it's working. So as I said before, the problem is when you are doing the selection of the column, we have to be so careful, otherwise this kind of error will come. So now the data is same as we saw in the graph. That is why I was like little confused why there was a problem. So if you want to remove that problem, just you can use the same thing by putting the dollar sign, because in all the cases the strain values are same. So to avoid that one, what you can do, you can fix that one also. But in this case I was little confused, and I took some time to fix that problem. So now everything is okay. So you do the same thing, just choose the data and go to the trend line and set intercept because it's 1 plus, so it is going to be 1, and then display on the chart. So if you see here, we got the C value which is 0.0858. Yes, so just copy and go here and check. It's similar. So the mistake I did was when I calculating the left side parenthesis, the strain value was keep on changing. It was A2. Then in this case, it was supposed to be C2, but it was B2. So when you are making this calculation, make sure that instead of putting data like this, just remove this column and just delete and then keep only 4 column. So for you, just if you want, just let me do, because that will save some time for you. So delete this one because the strain values are same. So it's okay. Even if there was a problem, I'm okay with it. So just go and select A1 and then double click, then same, select the strain value and then okay, delete, again select. So now everything is okay. So now you might get some clear idea. So when you are working with Excel, you might get this kind of problem, but it is not often. It's based on how well you are doing. So now we calculate the C data and finish it here. Let's move on to the M data. So this is same like C data, but in this case we have to consider the strain rate. So let's go into each strain rate, like 10, which is the reference strain rate. Just get all the data, just copy, come here and then paste it. So just delete all the strain value because last time we got the confusion, right? So this time just delete. Insert, this is strain and temperature 1, temperature 2, temperature 3 and then temperature 4. Okay. Now we have to do the similar thing. We have to calculate the left hand side and then right hand side. On the right hand side, before we have a dimensionless strain and this time we have a temperature. So for this you have to go to the paper and you can see the equation here. Let's make a crop. Here you might understand why in the first place I told you need a melting temperature. Just to go here, you can see screenshot. Just go to the paper. Let's give escape. Let's open the paper and then go here and now do the screenshot. And then keep that one. Okay, so first do the left hand side. First step, arrange all the model parameter. Better just go here and copy paste and then paste it. Okay, we got everything, and strain and stress. Okay, so let's do sigma, which is this, by the similar, which is A, put a dollar sign and then plus and then B, then make a dollar sign and then multiply strain which is here, and then power n. I think I didn't put the parenthesis, so it already put automatically. So okay, we have to do this 4 times. Actually it's a 3 times. I will explain why. We have to remove the reference temperature, which is this. I will explain why. So just copy and paste, and then here see the b value is going changing, so change that one to a. Now okay, and then do the same thing. So check this one more time. Okay, and then calculate the dimensional stress, because we are going to consider the reference temperature, right? So this one is always going to be the 0, so we cannot consider that one. I will explain when we are calculating the temperature value. So the reference temperature is going to be the first one, which is 1323 minus the reference temperature is same by the melting temperature, which is 1783 minus 1323. I think it's 1783. Let me cross check. No, it's 1783. So it's 1783. Oh, it's right. My memory is good. So 0, and then copy, paste, and here you have to change this one. So the second temperature is okay, just copy this one. Control C. So the another one is 50. This one, copy and then paste it. This is going to be 1423. And then copy, again paste it, and go here, click 73. So now we have to make a log. So we know when we are making the log of 0, we get no number, which is infinite. That is why we have to delete that particular value, and we have to consider only these 3 temperature when we are estimating this particular model parameter. So make sure that you will use only this 3 value, not this one. So this is the second temperature, third temperature, and then okay, I was little thinking the data is from here. So just copy, paste, Control V. Yes, use these 3 data, not this data, because in this case they chose the low temperature as a reference strain rate, reference condition, so you don't need to consider that one. So this one is now T2, and then T3, and then T4. So now let's make a log, which is going to be the Y1. So Y1 is going to be 3 times. So which is log of now just copy paste. So now you calculate the right hand side, which is x, and then now we have to do this one, right? So we already calculated this particular one, but we have to make a minus. So insert 3 times and then name it as a x1, sorry, that this one actually y, because it's on the left hand side, right? So it is going to be the y1, y3, and this one is x1, x2, x3. Okay, and then 1 minus this value, and let's make ln. Yes, here you make one more mistake. So here we have to always use absolute value, so don't miss that one. Now it will work. Yeah, this is another one important thing you have to remember. You have to keep always absolute value, and then copy and then paste. Yes, so this one I did like 3-4 years before, so that's I have a little problem when I'm doing this one, but it's getting better, so no problem. So you have to keep in mind that when you are estimating this particular parenthesis, you have to use the absolute value, otherwise you will not get the solution. So now let's arrange. Copy and paste, and then copy, paste it, then do the same thing, copy and paste it, Control C. Let me confirm one more time. See, we made a mistake. We have to use only these 3 data, not this one. So let's do this one C, and then this one has to be D. This one has to be E. So make sure that based on the reference condition, you didn't mess up the calculation of y. So this one's supposed to be T2, T3 and T4. But in the first step, I took like a T1, T2, T3 because I misunderstood the T4 was the reference condition. So make sure that when you are choosing the reference condition, your data should not be messed up. So you have to use T2, T3 and T4. So when you are using this tutorial for the first time, you might get some confusion, but after watching lots of time, you will get the idea. So now just copy paste and use it. So copy, which is going to be y. So let's paste it this side. Copy and then paste it one more time. And then y, copy and paste it one more time. Sorry. Copy and then paste it. So do the x1. So this is belongs to, make sure that this is T2. Yes, this is T2. Otherwise again you will get the problem. Paste and then copy, paste. So now you got x and y. Now we are ready to go. Just make a plot, data plot, and then shows the trend line. So the intercept here is 0. So set the intercept, display the equation on the chart, and then it's around 0.7. So the M value is around 0.7989. but in our case you can see 0.7989, right? 7989, and for them it got around zero point 0.6. So as I said before, this calculation differ based on this value because we are using these three value to make a final estimation of this particular parenthesis, right? So in this case, when we are using the previously calculated the parameter, that might affect a little bit. So it is not a huge problem, and you just consider this procedure for how you can do the estimation of material parameter. So now let's make all the combined together how we calculated. So the first one is A is 100 and the B is 78.7034. Copy and then paste it here, and the N is going to be 0.27 and C is going to be 0.08, and then this one is going to be around 0.7. Just format painter. So this is from the tutorial. So if you check the paper data also, you might see the difference. So just go here and you can see the final equation which is here. Just go and insert. So it is 100 and it's around 78 and 0.2416. I think it was calculated. It is very closer. No, I don't think so. Yes, this is the value. I put it wrongly here. Paste it. And then here, paste it. Yeah, 2708. And then 0.0858 and M. I think here what we put. Yes, that one. So there was no problem. So if you check the paper data and our data looks very similar, and there was no problem. So we did a proper calculation of all the parameters, and I will explain the two mistakes I did. The first mistakes, which was when we are estimating the strain value, it was supposed to be same for all the cases. So I did a miscalculation. When we are just copy pasting, it was jumping into like another column. So I just deleted and I kept only one strain values to make a estimation. So this error was fixed. The next error I was having, choosing the value which is supposed to be, we have to remove the reference temperature because we are getting an infinity value when we are making the log, and in that case I made a mistake. And one more thing, we have to make a absolute difference. When we are estimating this particular parenthesis, we have to make a absolute, not removing the absolute. Otherwise we will get the negative value and it will be resulted in the infinite number and we cannot make any curve fitting. So make sure that you always calculate the absolute value. So these two mistakes I did, and yeah, sometimes mistake happen. So sorry if there was a misunderstanding, and if you have any doubt, just try to post it in the comment. I will explain. Because this tutorial is not going to stop, I'm going to extend this tutorial to make in the MATLAB. So in this case, you don't need to worry about this Excel calculation. That MATLAB code give you, the next level understanding, because when you have any kinds of experimental data, you just input the data, just one click you will get all the output. So the MATLAB program will help you more than this Excel calculation. So wait for the tutorial and I will post it as soon as possible. And thank you so much for watching. Subscribe to this channel and share with your friends. So if you share with your friends, I will get more views and I will gain more subscribers, and that will help me to make more videos in the future. And thank you so much once again, and see you later, and see you in my next video. Thank you.